So to get the atomic mass or atomic weight, both those are the same thing. They are not the same thing as mass number, so try not to get the words confused. Mass number is for a specific isotope, just one of these, and the atomic mass is the weighted average of all of them. So in order to actually calculate the atomic mass, you need every naturally occurring isotope there is and how much it actually weighs. And so the mass number for each of these, we said it's 24, 25, 26. The actual mass of the atom is slightly different because a neutron and a proton don't weigh 1 AMU. They are a little bit more than an AMU, but as protons and neutrons come together in the nucleus, mass is lost because of the energy that's transferred. Einstein's equation. So some of the mass for the protons and neutrons that are in the nucleus gets converted to energy, nuclear energy. So these are the actual masses of these isotopes. And then you also need the percent abundance because the 24 isotope is not equivalent to the 25 because most of the isotopes are the 24. And so what you do to figure out the atomic mass is you take the mass of the isotope and you multiply by its percent abundance, but you do the abundance in decimal form instead of percent form. So you're going to take the mass times its abundance, and you're going to turn each percentage into a decimal number. So you'll multiply the mass times its abundance in decimal form. Then you want to add those three together, because if it was equally abundant, then you would add them and divide by 3, which is pretty much like multiplying each one times 33%, and then add them together. So when it's weighted, you do each one by its weight, and then every single one of them, you add them together, and that gives you the average. And then you're going to round it like the masses are rounded. So the masses are rounded to the thousandth place. So when you add these numbers together and you round it to the thousandth place, you'll get 24.305 AMU. Which is the atomic mass of magnesium. So there aren't any atoms that weigh 24.305. There are atoms that weigh 23.985 and 24.985 and 25.983. But when you get an actual sample that has magnesium in it, like for instance Epsom salt is magnesium sulfate, all of the magnesium ions that are in that sample are either magnesium 24, 25, or 26. And so if you had 100 ions or 100,000, 78.99% of those would have this mass, and 10% would have this mass, and 11.01% of those would have this mass. But what we would actually use to figure out the amount of magnesium we have would be the average, because we weren't looking at individual atoms, we were looking at a big sample. So the only time that we use mass number is when we look at individual atoms, when you're asked for mass number, okay?